Okay, so this is the Kirchoff's nodal analysis that you've been set. So you'll see that this is the same circuit. What I've done is I've called this first supply V1 and this second supply V2, and I've labelled these points around the circuit. That's to allow me to identify loops, and in those loops I'm going to identify simultaneous equations. Also, the second thing I'm going to do before I kind of get started is I'm going to look at where the positive sides of the batteries are, or the supplies. So the positive side's that long side, and I'm going to say that the positive side of V1 is where the current I1 is generated. And the positive side of V2 is where current I2 is generated. So I1 will come up past point A to point B, and it'll come down here. At point B, it will merge with I2. So if you remember Kirchoff's current law is that the currents entering a junction are equal to the currents leaving a junction. So the currents entering that junction at point B, I1 and I2, are equal to the current leaving. The current leaving is I1 plus I2. So now we're ready to look at these loops in turn. So the first loop I want to look at is the loop with the 8-volt supply in it. So in that loop, I've got the current coming round the loop, and it's this loop here. So it's that loop there. That's my loop that's got my 8-volt supply in it. Oh, lost me a bit of focus. There, it's back again. So it's that loop there, that loop that I've marked in the orange. So that loop, looking at my lettering here, is A, B, E, F. A, B, E, F. And in that loop, I've got my 8-volt supply. So 8 volts is equal to, now remember that V equals I times R. So watching this current coming round, I1 it is at this point. It's I1 when it flows through at that R1. I1 times R1. Continuing round the loop past point B, I've now got this current here, I1 plus I2. That's times that R2. And then my loop continues on past D, past F, back to the supply. So that's my first loop. So I've got a value for R1 and a value for R2, so I'm going to substitute those values in. So 4I1, R2 is 5, 5I1 plus 5I2. Then I'm going to pull together like terms. So I've got 9I1 altogether. And that's my first equation. So 9I1 plus 5I2. Now I'm going to have a look at my second loop. So the second loop I want to use in my analysis is this loop coming out from the positive of the second supply round here. So it's that one shown in yellow. And that loop, looking at my labelling, C, B, E, D, following it round. It doesn't really matter if you've written B, C, D, E. It doesn't matter as long as you've got the 4 points in that loop. My supply in that loop is the 5. Then following that current, I've got I2, which goes through resistor 3. And then again, as I follow round, I've got I1 plus I2. And that's times that R2. So I've got a value for R3, 8. And I've got a value for R2, 5. I1 plus 5I2. And I'm going to collect like terms again. sorry, I2 that was. So I've only got 5I1 plus 8 and 5 is 13I2. So multiplying this through again, I2 times R3, that's this current flowing through this resistor. Then I1 plus I2 times R2, which is this current flowing through this resistor. So I've got 8 I2s rather, here. And then 5 I1s plus 5 I2s here. Collecting like terms, I've only got 5 I1s and I've got 8 plus 5 I2s. And that gives me my second simultaneous equation. So now I have to solve these simultaneous equations. So looking at these two, I'd look for something that either is common to both of them, similar of both of them. And to me, the thing that I look at straight away is I think, well, 5 nines is 45. So I'm going to multiply my first equation by 5. So 5 eighths, 40. It's 45 I1s plus 25 I2s. And that'll be equation 3. Because I've looked at this equation and this equation. And I've noticed that if you multiply 9 by 5, you get 45. If you multiply 5 by 9, you get 45. So that's why I've chosen to do that. My second equation, I'm going to multiply it by negative 9. So that in my first equation, I've got 45 I1s. And in my second equation, I'm going to have negative 45 I1s. So let's start with this at the start first. So I've got minus 45 is minus 45 I1s minus, multiply everything in the simultaneous equation by the same thing. So I'm going to multiply 13 by that negative 9. So it's minus 117 I2s. And that gives me my equation 4. Now I'm going to add these two equations together. So I'm going to add equation 3 and equation 4. And you'll notice when I'm referring to equations, I put my numbers inside these circles, just so that I know that they're references. And when I'm using actual numbers to multiply, I use the number on its own. So 40 plus minus 45 gets you negative 5. 45 plus minus 45 gets you 0, that cancels out. And then I've got 25 plus minus 117 gets me negative 92 I2s. And then all I have to do is take this across to this side, so I get what I2 equals. So minus 5 divided by minus 92 is I2. So minus 5 divided by minus 92 so that gets me a value of I2 as being 0.543 to 3 significant figures. 0.0543 amps. And that's my value for my I2. So now I'm going to use this value for I2 in one of my equations, so in equation 1, 2, 3 or 4, so that I can work out what the value for I1 is. So I'll go over to this part of my page here. I'm going to take this value and I'm going to substitute for I2 in equation 1. One's as good as any, doesn't make any difference which one you choose. So 8 equals 9 I1s plus 5, and it's times that value for I2. So I'm going to work that out. Five times 0.0543. Nope. And that gets me 0.2715. And now I'm going to solve this equation. So I'm going to move this across to the other side. So it's positive on this side, becomes negative when I move it over. I'll work that out. So that gives me 7.7285. We'll just keep the lot. And then when I move this over, instead of it being 9 times I1, this will go underneath. So that gets me 0.85. Going 3 significant figures, so 0.859. That's got me current I1 and current I2. So I've got my value for I1 here, and I had my value for I2 here. And what I'm looking for is this current here, I1 plus I2. So to get I1 plus I2, I'm simply going to add my answer for I1, my 0.859, and my answer for I2. So 0.859 plus 0.0543, and that gets me 913.3 milliamps, or 0.9133. So 913.3 milliamps. And then to get the voltage across that same resistor R2, the voltage across it's going to be the current through it times the value of it. So it's just V equals I times R. So that V2 I'll call it VR2, so it's clear. Voltage across resistor 2 goes that current 0.9133 times the value of my resistor 2, which is 5. And that gets me 4.567 volts. So I've rounded to 4 significant figures, that's 4 significant figures. They should be fine. And that's that Kirchoff's nodal analysis completed. You could work out the voltage across any other resistor by doing I times R as well.